So now we're going to look at some more complex ones in part 3. So we have O2. So that has 6 valence electrons, and there's 2 of them. So we have a total of 12 valence electrons we need to model. Nothing really to go in the center, just oxygen and oxygen. We have a pair, bringing them together. And then each nonmetal will need 8, so 6 unshared valence electrons. And then we see, what do we got? 2, 4, 6, 8, 10, 12, 14. That's not going to work. So when single bonds don't work, we need to do multiple bonds, like a double bond. So instead of having 1 pair of electrons shared, we have 2 pairs shared. Now that means each oxygen currently has 4 valence electrons. Now this one has 6, now this one has 8. That one is done. This one has 4, has 6, now has 8. Doesn't matter where you put them. Let's count them up. 2, 4, 6, 8, 10, 12. Very good. Next, let's look at N2, nitrogen. It's in group 15, so it has 5 valence electrons. There's 2, so a total of 10 valence electrons. So nitrogen, give its 8 electrons. 2, 4, 6, 8, 10, 12, 14. Not going to work. Let's try a double bond. Again, we're just doing kind of mirroring what I did above. 2, 4, 6, 8, 10, 12. Again, not going to work. Let's try sharing 3 pairs of electrons. So that means each of them currently have 6. Now this one has 8. Now this one has 8. 2, 4, 6, 8, 10. Yay! Alright, let's do CO2. I'm going to do it up here so I got a little room. Carbon in group 14 has 4 valence electrons. And then we have 6 valence electrons for each oxygen. Gives me a total of 16 valence electrons. Now, carbon should go in the center with oxygens around it. Doesn't matter where. We'll make our single pair. 8 valence electrons around everything. And count up what we got. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's not going to work. So I can see I'm short like 4 valence electrons. So instead of just doing 1 pair of electrons, that'll gain me 2 less. Let's try 2. So carbon and oxygen. Should get my little oxygens first. Try sharing 2 pairs of electrons for each. So right now carbon has 8. 4 here, 4 here. So that means each oxygen has 4. Now they have 6. Now they have 8. Has started with 4. Now it has 6. Now it has 8. Now I should count up what we've got. 2, 4, 6, 8, 10, 12, 14, 16. There we go. Now we come down to our most complicated one, C2HCl. So for starting off, we have 4 valence electrons for each carbon, plus the 1 valence electron for the hydrogen, plus 7 valence electrons for chlorine. So that's 8, 15, 16 valence electrons. Now carbon needs to go in the center, and there's 2 of them, so they should equally go in the center. Now when you have H and Cl, it's like, well, what happens here? Do I put H and Cl? Or do I put H on one and Cl on the other? Well, what I always put it to is that it's highly unlikely that something were to have 2 atoms around 1 and another one have 0. So let's put the H over here, Cl over here. We need to bond everything with a pair of electrons, because everything should have at least 1. Hydrogen should be good. This carbon has 4. Now it has 6. Now it has 8. This carbon has 4. Now it has 6. Now it has 8. This chlorine has 2, 4, 6, 8. Count them up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that will not work. Let's try making a double bond between the carbons. So carbon, carbon, hydrogen, chlorine. So therefore single bond, double bond, single bond. This carbon has 6, now it has 8. This carbon has 6, now it has 8. This only has 2, so we need to fill in everything else over here. And count up our electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18. Still too many. So when double doesn't work, let's try triple. So I'm going to just put my triples here. Single pair of electrons over here for hydrogen. Got my chlorine. And now I've got 8 around that chlorine. So let's count them up. 2, 4, 6, 8, 10, 12, 14, 16. Da, 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 da. So again, after you do some practice, you'll see you probably don't need to go through this kind of marching orders in order to get to the final answer. You'll have some experience in your pocket. But at first, try single bonds. If that doesn't work, start doing double bonds. There's only going to be a few things that you can do that with, so that's where you're going to be. Come with any of your questions. Oh, wait, actually we got our last bit. How would you name this molecule? That's easy. It's sea water. Sea water. Answer the final questions at the bottom of your page and come in with any questions you have. See you soon.